Hey guys, welcome back to Pipe vs YouTube channel where curiosity meets the code. Today our topic of discussion will be understanding the challenges in imbalance classification. So let's get started. Firstly, the contents. Firstly, I'm going to show you the explanation of what is imbalance classification. Then we are going to go through the challenges for traditional models, the impact of imbalance, common scenarios of imbalance datasets, need for specialized evaluation matrices, confusion matrix for imbalance classification, precision for imbalance classification, recall for imbalance classification, precision versus recall for imbalance classification, and then we have F measure for imbalance classification. So firstly, what is imbalanced classification? Imbalance classification is a method where we encounter a scenario where a distribution of classes in the dataset is significantly skewed, with one class being much more prevalent than the others. For example, take in fraud detection, where the occurrence of fraudulent tax transaction is rare compared to the legitimate transaction. We face a classic case of imbalanced classification. Now, what were the challenges for traditional methods? Firstly, being briefly explaining that the conventional machine learning models are designed with assumption of balanced class distribution. The channel posed will be the prevalence of imbalanced dataset poses challenges for traditional models, leading to biased learning and symposial performance. Then what is the impact? So the consequences being emphasizes that the imbalance in class distribution can result in models being overly biased towards the majority class, leading to poor predictive performances for the minority cases. Second one, we have misleading accuracy. So, highlighting that the accuracy alone may be misleading in such scenarios, as a model might perform well in predicting the majority classes but poorly for minority class. Then we have some of the common scenarios of imbalanced dataset. Firstly, I have already told you this example, fraud detection. In fraud detection, the occurrence of fraudulent transaction is relatively rare compared to the vast number of legitimate transaction. So, what is the example here? Consider a credit card transaction dataset where fraudulent transaction represents only a small fraction of the overall transaction. Secondly, we have disease diagnosis. So, in medical diagnosis, certain diseases or medical condition may be rare compared to the general population. So, imagine a data set of a rare genetic disorder where positive cases, which is individuals with the disorder, are significantly outnumbered by negative cases with those without the disorder. Thirdly, we have rare event prediction. So here predicting rare events such as equipment failures or system crashes can result in imbalanced data set. Example being in predictive maintenance for machinery, the instances of actual failures might be infrequent compared to the normal operation instances. Then we have anomaly detection. In anomaly detection, it involves identifying usual patterns or outliers, making positive instances, which is anomalies, less frequent. The example of this being in network security, detecting cyber attacks involves identifying rare patterns in network traffic among a majority of normal activities. Next, what is the need for specialized evaluation metrics? Firstly, the limitation of traditional occurrence matrices. So, traditional accuracy start by acknowledging the common reliances on accuracy as a metric for evaluating the models. Then we have shortcomings and of emphasize the traditional accuracy matrices that may not provide an accurate representation of model performance in imbalance scenarios. Secondly, we have introduction to class imbalance. Understanding class imbalance introduces the concept of class imbalance, where one class significantly outnumbers the others in the dataset. The channel post here is explained that the class imbalance poses challenges for machine learning models, as they may become biased towards the majority class. Thirdly, we have importance in specialized evaluation metrics. So we have comprehensive understanding. Highlight the need for specialized evaluation metrics tailored for imbalanced data set. Then we have differential impact of errors, which is mentioning that the false positive and false negative can have a consequences in imbalanced data set. For example, in fraud detection, a false negative might have more severe consequences than a false positive. Fourthly, we are choosing matrices that account for differences, that is, decision impact. The stress importance of sleeping matrices that consider the consequences of different types of errors. Then we have precision and recall. Introduce precision and recall as matrices that provide a more nuanced understanding of model performance in imbalance scenarios. Like what about confusion matrix for imbalance in classification? Firstly, in realm of classification, the landscape of classification task, a confusion matrix emerges as a pivotal and indispensable tool. The assessing model performance, its primary purpose is to provide a comprehensive and structured assessment of the model's performance, going beyond the traditional occurrence matrices. Next, some of the elements of the confusion matrix being the true positive. True positive represents the instance where the model correctly identifies as a positive class samples. Then we have true negatives. True negatives accounts for instances where the model accurately predicted negative class samples. Then we have false positive. False positive denotes instances where the model made incorrect positive predictions, triggering false alarms. Then we have false negative, which is false negative signifies instances where the model incorrectly predicted negative class samples, resulting in missed detections. So here is a representation of confusion matrix. You can pause the screen and go through it. So how were we evaluating performances in imbalance scenarios? Firstly, highlighting the imbalance. Imbalance classification scenarios such as direct attention to significant of imbalanced data set in certain classification scenarios. Then we have crucial role of confusion matrix. Emphasize the invaluable role of the confusion matrix in such situation. Thirdly, we have visual aid. Consider using visuals or examples to illustrate the skewed class distribution. Next, we have the imbalance impact. So, influence on traditional occurrence matrices. Discuss how class imbalances can exert a substantial impact on traditional accuracy matrices. Then we have overemphasizes on TNS address the potential overlaps on true negatives such as TNs in imbalanced dataset, potentially leading to misleading interpretation. Then we have need for nuanced evaluation, emphasize the importance of nuanced evaluation matrices, highlighting the limitation of relying solely on occurrence. Then we have utilizing confusion matrices. Firstly, precision and recall, direct derivation, that is precision, which is positive predictive value, and recall is sensitivity, can directly calculate from the element of the confusion matrix. So precision formula being precision is true positives divided by true positive plus false positive. Then recall formula being true positive divided by true positive plus false negative. Then we have a brief explanation, which is precision emphasizes the accuracy of positive prediction while recall focuses on model's ability to capture all positive instances. Next, we have the importance. Nuanced evaluation emphasizes the importance of precision and recall in providing a more nuanced evaluation of model performance. Then we have imbalanced dataset, highlighting the matrices are particularly valuable in imbalanced dataset where the consequences of false positive and false negative may differ significantly. And then we are having balancing act, the stress, the need for imbalance consideration of both precision and recall to make informed decision is classification tasks. Next, we have precision for imbalance classification. So, what is precision for imbalanced classification? Before that, what is precision? We already know the formula. Precision is defined as a ratio of correctly predicted positive observation, which is true positive, the total predictive positive plus the false positive. So the formula being TP, which is true positive divided by true positive plus false positive. The importance of precision being addressing imbalance, discussing the heightened significance of precision in imbalance classification scenarios. Then we have rare positive classes, which is emphasize that precision become particularly crucial when dealing with imbalanced data set, especially when positive class is rare. The example being used a practical example such as fraud detection, where the occurrence of a fraud is infrequent compared to legitimate transaction. Then we have insights into accuracy of positive prediction. Precision as accuracy metrics explain how precision serves as a specific accurate metrics for the positive prediction. Then we have minimizing the false positive, discuss how precision minimizes the occurrence of false positive, which is vital in scenarios where misclassifying positive instances can have significant consequences. Then we have the balancing act, which is highlighting that the precision provides a balance between correctly identifying positive instances and avoiding false positives. Next, what is recall for imbalance classification? Again, recall, also known as sensitivity or true positive rate, is defined as a ratio of correctly predictive positive observation, that is true positive to the actual positive, which is true positive plus false negatives, which is Fn. So the formula being true positive divided by true positive plus false negatives. So the significance of imbalanced data set, firstly we have capturing all the positives, that is emphasize the primary role of recall in capturing as many positive instances as possible. Then we have imbalanced scenarios, discuss the heightened significance of recall in imbalanced data set where the positive class is rare. Example, use a practical example such as disease diagnosis where we're seeing positive class, which is false negatives can have severe consequences. Next, we have crucial role in consequence management, which is missing positive cases. Explain how recall is crucial in scenarios where missing positive cases can have significant consequences. Example B of scenario being illustrate a scenario such as medical diagnosis where failing to identify positive cases might lead to delayed treatment or increased risk. Next, this is the illustrating the trade-off, which is precision versus recall for imbalanced classification. So you can see the precision graph and a recall graph for imbalanced classification. Next, here is the precision versus recall classification. So we have false negatives and true negatives. The precision is true positives divided by the entire thing. The recall is the true positives divided by only the true positives. Then we have F measure for imbalance classification, defining the F measure. So F measure, also known as F1 score, is defined as a harmonic mean of the precision and recall. The formula given by 2 into precision into recall divided by precision plus recall. Combined metric for precision and recall. Harmonic mean concept explains how the F measure harmonizes precision and recall by taking their harmonic mean. Then we have the balancing act, which is discuss how F measure provides a balanced evaluation by considering both false negative, which is precision, and false negative, which is recall. Next, we have the usage of imbalance classification scenarios. So considering both matrices, the F measure is particularly useful in imbalance classification scenarios where striking a balance between the precision and the recall is crucial. The decision threshold discuss how F measure can be especially informative when there is a need to optimize both precision and recall without favoring one over the other. So that's it for how to deal with what is imbalance classification. If you want to know about any other topic, comment down below. Thank you so much for watching. If you have learned something from this video, please do like, share and subscribe to our channel. Thank you.